Welcome to track 3 of day 2 of the Diana Initiative. Our next talk is going to be about leveling up in the cyber world. But before we get to the pre-recorded version of this talk, and then there'll be Q&A with the actual presenters, I just want to take a moment to thank our sponsors, MongoDB, Microsoft, Amazon, Intel, Remediant, Thermo Fisher, Coinbase, Scarphone, Cybersecurity, Kazo, and many, many others. Without our sponsors, we would not be able to accomplish any of this. And to remind you that today, our final keynote will begin a little bit later than is on the schedule, about 30 minutes later, so that everyone can wrap up the villages, which you should be visiting. The Career Village, the Makers Village, the Red Team Village, and even the networking area where it just pairs you up with someone random, which is a pretty fun little place to do that. So without any further ado, we are going to begin watching Leveling Up in the Cyber World featuring Meenakshi SL and Sandhra Bino. Roll the tape.
So, gender gap in cybersecurity, no women in cybersecurity. We all have read articles about it, and there are a lot of reasons why. But hey, we're women in security, and we are here for a reason. Today, we'll be introducing you to the world of cybersecurity in the most beautiful way, that is, through CTFs. By the end of the talk, you'll know what a CTF is. You'll be introduced to the two fields, reverse engineering and cryptography. Finally, we'll also give you some good resources to learn and also some good tips to help you stand on your own feet in the world of cybersecurity.
Hi guys, I'm not sure how I should greet you all because it's morning for some of us and it's evening for a few others. So I'm just gonna say good morning to all of you. And to talk about us, we are students from India and we're currently doing our 5th semester in computer science engineering. And I'm sure by now you guys are wondering what these kids are doing around here. So we are the members of a cybersecurity club back in our college. The cybersecurity club is called Team BIOS. We are also members of a CTF team called Team Shakti, and both the teams are CTF teams. And since you guys are already here, let me guess you heard about CTFs already. So both our CTF teams, Team BIOS and Team Shakti, are ranked among the top 20 teams in the country, and Team BIOS is actually ranked first in our country. So basically, what I'm saying is, we play CTFs for almost most of the part of the year, and more than even attending college classes, we actually play CTFs. We organize CTFs like in CTF J, in CTF National, in CTF International, to encourage students from schools as well as colleges to develop their skills in cybersecurity and basically computer science. Moving on to the agenda for the day, I'm sure most of you here have heard about CTFs at least. So we'll be introducing you to the various categories mainly found in CTFs, and we'll be diving into two of those, that is reverse engineering and cryptography, like Meenakshi said earlier. And later we'll also be talking about how we formed a CTF team and how important it is to have a CTF community and how much it has helped us, not just technically, but also in improving our teamwork and team leadership skills. So now, what is a CTF? What is it? So when we joined college for computer science, our ultimate aim was to be a software engineer by default. And knowing more about CTFs, knowing more about the field, we actually got a clear picture that CTFs are just as important to cybersecurity as coding and problem solving is to become a software engineer. So first, we talked about how important CTFs are and why it is important. So now I'm going to talk to you guys about the different types of CTFs that we have. Now, firstly, Jeopardy CTFs basically have challenges from different categories which can be solved locally on your machine, and we can just obtain the flags from our local machines. And in attack and defense CTFs, we have all the teams in an registered to an attack and defense CTF are connected to a server through a VM provided by the organizer, which has services running and flags are planted in all the VMs at the same time. Teams attack other teams and teams basically have to find the vulnerabilities in their own machine, and they have to attack the other machines and grab their flags to submit them. So that's an amazing way of learning how to find vulnerabilities. And again, we have to patch our machines after finding the vulnerabilities, and that is how, and again there you know how to protect your systems from such vulnerabilities.
But hey, what's the point? You could just do some certification courses and get some training. But what kind of stuff allows you to have fun while learning? What kind of stuff allows you to game, make friends, collaborate with your team, and still, learn about the latest vulnerabilities in software? Yes, that is what CTFs are all about. So the classical categories in CTFs include cryptography, web exploitation, reverse engineering, forensics, and bonding. Now, some of the newer categories include OSINT, hardware pen testing, and some even include satellite hacking. Let's dive into the main stuff. So Sandra is gonna guide you through a reversing session. I'll be handing over the mic.
Okay, so hi again, and like I said before, we will be dealing with the two main categories in CTF, that is reversing and cryptography, and I will be talking about reverse engineering. So let's dive right into it. Today we'll be covering the following topics in reverse engineering. Before going ahead with the topic, let me just give you a heads up that it is definitely not something you can learn in a month or two, let alone 45 minutes. So our idea today is to give you all a head start on how to get started with playing CTFs, and we'll talk about the central patterns in CTF challenges, and how to approach a challenge when you get a binary, and what do you do when you're stuck. Finally, we'll also be solving a simple crack me and a little bit about automation. So intro into RE. So reverse engineering is the process of analyzing and understanding a system or a process, and is not solely restricted to software. Hardware can be reversed too. So basically anything you can think of, like cars, watches, televisions, anything can be reversed. Or let me just generalize it as anything that runs on code can be reversed. And I find that extremely cool, because if it's code, it can have bugs, and these bugs are exploitable, and that just makes everything exploitable. And these days everything is coded. When I say reverse engineering, these are the things that pop into my mind: assembly, library functions, memory mapping, control flow. So once you've solved or gone through the assembly once and figured out the control flow of program, it is as simple as reading words from alphabets. It all fits the frame, because nothing is more logical than a piece of code. Every instruction makes absolute sense, and every instruction is there for a reason. The easiest way to start learning reverse engineering is to go pop a shell, write your own hello world program, and compile it and debug on your own. So, disclaimer alert that we use a Linux machine 90% of the time. A Linux-based environment is what we work on. So most of the commands that I'll be using here will be Linux-based commands. So here we are playing a CTF and we get a binary. And what do we do? So generally speaking, we follow these three steps in the following order to finally get to the flag. That is breaking down the ELF, that is viewing the code somehow, and then analyze the code and find a vulnerability, and then finally exploit the vulnerability to get the flag, just like you get the exploit and exploit the tool. Next, we move on to the types of challenge files that we have in a CTF challenge. So any code or memory dump can be reversed. Anything can be reversed that runs on code. So these are the general types of files we get for a CTF. It can be practically anything, but these are the ones we frequently encounter. ELFs and .so files are Linux executables, and they are the most common ones. The next one that we have are EXEs and DLLs. Those are Windows executables, and sometimes we even get Python bytecode, that is the .pyc files. And those are really fun to play with. And the rest are Excel sheets, Game Boy ROMs, CPU snapshots, and whatnot. Next we'll be talking about the tools and tricks that you need to solve the CTF challenge. And before we talk about the tools, let's talk about the prerequisites. And I would suggest every one of you to have all of the prerequisites above when you attempt an RE challenge. RE as in reverse engineering. So the minimum prerequisites would be C and C++, and the working of pointers is very important for starting with reverse engineering challenges. When you analyze a code, when you analyze assembly code, you have to know how the memory works. Assembly language, preferably x86, 64, or 32, and how the stack works, basically the memory. Working with the basic command line tools or bash commands. And there are two kinds of analysis approaches, that is static and dynamic analysis. In static analysis, you analyze the code without running the binary, and in dynamic analysis, you run the binary and analyze it at every step of the execution. And the tools you will be using to do the previously mentioned static and dynamic analysis are the following. In Linux, we'll be using these tools: Object Dump, GDB, or GDB Peda, which is an advanced version of GDB, Ghidra, R2, or Cutter. Cutter is the UI version of R2, that is Radar. And the popular tools on Windows are Ghidra, IDA, x86-64, x64DBG, x32DBG, WinDBG, and ILSPY. And for the in static and dynamic analysis, it is classified into three, that is disassembly, debugging, and decompilation. Disassembling a code or an executable is extracting the assembly code from the executable itself using the machine code, which is unreadable to humans. Excuse me. Debugging a binary is running the binary on a tool which stops and interrupts the program after every single instruction and helps you analyze the state of the program after every single instruction is executed. Decompilers are the most advanced among the tools here. It basically provides you the code of the program from the binary itself. And for decompilation, an amazing example is Ghidra, which is a free and open source tool. Many others are paid. So Ghidra is the best option for decompilation. Next is the approach that you have to follow when you're solving a CTF challenge. This is the approach that I would suggest when you're starting with reversing. So first you run the strings command to dump all the strings from a binary. Next is the file command. The strings command is used to dump all the strings from binary, and similarly the file command is used to dump all the details of the file, such as what the file contains and what is the file type and the 64 or 32-bit binary. Next, you execute the binary to see what the program does. And next, you disassemble and decompile using IDA, Ghidra, Radar, and Object Dump for static analysis. And next, I would suggest you to analyze the path traversed by the input by static or dynamic analysis, or just figure out the control flow of the program. Functions and their arguments. On statically analyzing, you have to find out the functions in the program and the arguments that each of these functions take. That will be very helpful because when you see your input going through a function and coming out as something else, then it is important, right? So that has to be analyzed. Later, dynamic analysis can be done using Radar, Ghidra, or GDB to check in detail through the program what happens after each and every instruction. And in reverse engineering, we're often stuck with a problem because it took too long to analyze and it's hard to move on because there is a report or too much mathematics involved, and that's when we play our next card, automation. So when all that sounds monotonous, we'll play our next card, that's automation. Ever heard about SMT solvers? Okay, so SMT solvers are the tools that we use to solve multiple mathematical relational equations which are generated in the program. And these SMT solvers completely change the face of reverse engineering. So we'll be solving a quick crack me from Pico CTF. Let's dive into it. First, we run the file command on the executable, and it shows us that it's a 32-bit executable, LSP ELF executable, and we run it to find out what it does. Next, we run the strings command on the file, and it chooses all the strings that are inside the file. We grep it to less, pipe it to less, and here we have all the strings we find when we run the program manually. Next, we run the binary through the tool Ghidra that I mentioned earlier, and here you have in the symbol tray all the functions that are called and all the labels and classes that we have in the program. And we go to the main from functions. Here on the right side, you can see the decompilation of the code, and on the left side, you have the disassembly. So on the decompilation side, you have basically the code that generates this binary, so that is much more easier to analyze. And when you click on the decompilation on every function, it directs you to the corresponding disassembly on the left side. Here we have the do magic function, which seems to be doing some operation on the function, operation on the input. So here we have the input taken and input length being assigned to a value, and there is a while loop. So in the while loop, you can see an incrementation in the code highlighted right now. And you can see that there is a SOR operation happening, which is being checked with the greeting message. So you have the input underscore s, and we're renaming it as the input itself, and the index of the input is ordered with the same index of the secret buffer that we have in the code. And double clicking on secret buffer actually dumps the secret buffer on the left side. Here we use GDB to actually dump the values from the executable. We take the buffer of the values from Ghidra and use it to dump the values on GDB. Here we have the 25 values that we got from the address we found using Ghidra. And next we use the greeting message. And these both values are resolved together to get the final input that we have, that we want. Excuse me. Next, I have already written a script here that does the following. That is, take the secret buffer and takes the string, the greeting message, and it sorts both the strings to get the value. So here I'm also writing another function which actually does the same, but in a simpler format. It appends to the list the XOR value of the string, input string, and the secret buffer. And finally, it joins it as a string and prints it out. Okay, now let's run the code. So here we are done with our first crack me ever. Hope you guys understood as we went through each and every step. So moving on, what do you do when you have 100 equations or 1,000 equations to solve? You know, practically impossible to do it manually. Well, for that we have our math buddy Z3, the SMT solver, which I mentioned earlier. So talking about Z3, we have on the left side we have a checker written in C, which takes a 14-character string as input and has 14 checks to check each of its characters. So and it has exactly one output. So on the left side we have the Z3 solver for the same checker, where each of the constraints in the checker are added as each of the checks in the checker are added as constraints to the solver. Here the solver is S is equal to solver, where S is the solver object, and S dot add is the method used to add the constraints to the solver. And on running this module, it will give you a model. The solver will have a model object, which is the result of the checker. So, like I said before, this talk will help you understand how to get through with the CTF challenges, and that you have to have a little bit of prior knowledge while attempting these RE challenges. So these are some of the resources I recommend you guys to highly check out and learn these prerequisites. So firstly, I have the BIOS wiki to learn the stack and the assembly language. It also has a walkthrough to all the challenges from all the categories, not just reversing and cryptography, but all the categories, which will help you out to a great extent. And following the BIOS wiki, we have links to YouTube playlists that I have personally followed to learn Python and C language. Next, we have the CTF challenge archives from Pico CTF, which is yet another great set of beginner level challenges. It's actually a high school CTF, and it's a great way to get ahead with CTF skills. I have also added the DEF CON archive of challenges. That is a archive.000, where you have all the previous DEF CON challenges as well as other sets of CTF challenges to start learning with. So hope you guys check it out. So that's enough reversing for the day. Now moving on to ciphers and codes by Meenakshi.
So what is cryptography? Today we'll discuss about what is cryptography. We'll discuss about the different types of ciphers and RSA, AES, and some resources. So moving on, what is cryptography? Now suppose you send a mail to your friend. You send it through a public channel and anyone can basically eavesdrop. How do you know that only you both can read it and not an eavesdropper? That is where crypto comes into play. Now, before you move on, we have to be familiar with some basic terms, which is, okay, let's take an example and just learn. Suppose you send a note to your friend in class and you want to play a prank, let's say, and you write attack it down. Now, you don't want your entire prank to be a flop because the teacher got the note. So what you do is shift each character by 2 letters and then write it down in the note and then send it to your friend. Now your friend would know what the original message is because she knows that your lucky number is 2 and she just needs to shift the letter back by 2. So if the teacher gets the note, it's just a random chunk of letters. Now this encryption scheme is called Caesar cipher and is example of a classical cipher. It is aptly called so because Julius Caesar used to use this encryption in his time. But here, here the message is called the plain text and the random piece of junk is called the ciphertext. Now the sender, your friend, is the receiver and the teacher is basically the encoder or eavesdropper. The key is 2 and the encryption algorithm used here is Caesar cipher. But hey, that's too simple and easy to break. Now, it's just you just have 26 letters and you just have to brute force 26 letters and be over in a matter of seconds. So that is why we need stronger crypto systems. So let's move on to the different classifications of crypto systems. So basically, crypto systems is divided into 2: symmetric key cryptography and asymmetric key cryptography. In symmetric key, you have the same key for encryption and for decryption. While for asymmetric key, you have a different key for encryption and different key for decryption. You also have a classical and modern cipher. In classical ciphers, you have transposition and substitution cipher. You also have stream and block cipher. In stream cipher, you encrypt character by character, but in block cipher, you encrypt blockwise. So within a single block, even if we change one letter of the plain text, the entire ciphertext changes. Today, we'll be discussing about AES, which is asymmetric block cipher, RSA, and asymmetric cipher, and we'll go through some examples of encryption and decryption with Python using the PyCrypto module. So let's move on to AES. AES is symmetric block cipher, which means the same key is used for encryption and decryption. It is done block by block, so your message has to be a perfect multiple of the block length. And so there are different modes of implementation of AES. The basic box remains the same, but when more than one block comes, the implementation will differ. First, let's look at ECB, which is the simple, straightforward method. So as you can see, one block is entered into the encryption box. The next block is entered into the encryption box, and you get the ciphertext. So you can see that two adjacent blocks are independent of each other. So even if they're same, you get the same ciphertext. Now let's see how that is different from the CBC mode of encryption. Now, as you can see in the arrows, the plain text is first XORed with the previous ciphertext before being sent into the encryption box. So even if two adjacent plain texts are same, the ciphertext you get are different. Now, like this, there are a lot of modes for AES, but we think that instead of you can just check it out later. Now we'll move on to the demo of encryption and decryption. So here we'll be using a PyCrypto module, which is a module which provides modules for basic encryption and decryption. So you define the message. Here, this is a secret SMS, and the key is AES 16. What we have to note here is that it has to be a multiple of the block size. And for AES, it is 16. And the key size can be 16, 32, or 48, depending on what AES scheme you're using. So you define an object, AES equals to AES.new. Now to encrypt, you just basically need to do AES.encrypt append, and you get the ciphertext. That is the ciphertext. Now let's go to decryption. Decryption is as simple as doing AES.decrypt of cipher, and you get this as a secret. Now remember that it's a block cipher. This means even if you change one character of the plain text, the entire ciphertext should change. So here you see this is a secret. I changed the letter C to B, and everything else is same. Key is AES 16, AES, etc., etc. So if you see the previous slide, it's here it is XCD, XFC, XB8, PAT, etc. But in the previous slide, let's move on to the previous slide. Yeah, it is A6, F1, 8EB, and so on. So you can see that both are completely different, even if you just change one character of the ciphertext. Now, before we move on to details, I think it's better that you have to do hands-on, and you should do something on your own so that it just gets into your brain and just gets written there. So I want you to, it would be nice if you just try out this point after the talk. That is, see how it differs for, say. So RSA is reverse Shamir Alderman. So it's an example of an asymmetric cipher, which means you have one key for encryption and another key for decryption. Let's dive into some math. So RSA is based on complexity of prime factorization. Basically, doing 7 into 11 equal to 77 is easier than doing 77 equal to 7 into 11. You could just write a Python script to do it, right? Okay. So what if I say factor a very huge number such as 1, 0, 8, 5? Yeah, this big number. Now you see what the problem is. So for RSA, if you have a 1024-bit key size, a computer will take more than like 2000 years to just prime factorize it. And that is the strength of RSA. Now let's see how all of this fits in. There are mainly 3 steps to a perfect encryption. So first is generation of 2 strong primes and then defining the public key. Now finding the inverse and producing the private key, and then finally encryption and decryption. So first let's see generating the public key. Now you import the necessary modules, generate the primes, p equal to get prime of the how many bits you need. Here it's 128, q and n equal to p into q, and e is equal to 65537. So the pair n comma e is called public key because it's public to all and you can just share it with anyone. Now let's see how we'll create the private key. So you define a variable called phi, which is equal to p minus 1 into q minus 1, and there's d is equal to inverse of e with respect to phi. Now notice here that phi can be generated only if you know the prime factorization of n. And since, if you remember, the problem is very hard, so this is private to you, and unless you share it, nobody knows the private key. So d is called our private key. Now let's look into how you encrypt and decrypt stuff. So you have the message, you convert it into int, and yeah, there you go. And for encryption, you just raise it to the power of e mod n, and you get the encrypted message. Now to get the decrypted message, you just need to raise it to the power of d, and you get back the original message. So it's safe, right? Not always. Sometimes n can be factored very easily, and there are various reasons why. One of them is that the primes sometimes are very close to each other. So let's take the root of n, and if you take the factors, since they are close, now the root will be kind of close to p and q, which is our factors. So you could just brute force to obtain those values of p and q, and since they are close, it won't just take a lot of time. Now, Fermat's attack is kind of a more optimized method to kind of implement it. So you take the root of n, and b is equal to a square minus n. While b is not a perfect square, you should increment a and then update b. Now b will be a perfect square only when you get the correct value of a. Okay. Now finally return a minus root b. You could do it in a much more simpler method by just taking the root of n and then increment it by 1 till a is equal to a factor of n. You can do it in both ways. So let's take a sample scenario. So this is the challenge called weak RSA from Pragyan CTS. They have given the value of n, and we have to find p and q from it. Now we calculate the root of n and store it in a, and we calculate b equal to a square minus n. Now b is a negative number, so since b is less than 0, it can't be a perfect square. Now you just keep incrementing it. And at one point, when you increment a equal to a plus 1, b equal to a square minus n. And at one point, you will get b as a perfect square. See? Now we can find p from that. P will be equal to a minus the square root of b, and q will be n divided by b. So thus, we have found the factors of p and q without just directly brute forcing n. So you can have further resources for this. You have to learn the basics of modular multiplication and stuff. And there are a lot of attacks which may facilitate factoring RSA only if you know n and so on. Now these are some of the resources which I found useful for my study. First is Krypton, which is an educational library written by one of our team members, and it consists of the most common ciphers used for CTS and the corresponding attacks and some challenges for it. So CryptoHack is a war-based game war game kind of thing. So, but it's for corporate samples. And obviously, you have to look at past CTF samples. But again, good resources are not everything, isn't it? And we just got started.
So, when you play CTFs, getting stuck almost becomes a habit, but getting along with getting stuck, you learn to get back up and find new solutions, right? And finding solutions by breaking down the problem, googling effectively, and most important of them all, learning to ask. Okay, but that brings us to the next topic, next big thing in cybersecurity, that is socializing. Wherever you go, there are platforms for cybersecurity people to network, because cybersecurity, in cybersecurity, it is very essential to keep track of everything new and be ahead of the hacker. So socializing to a great extent helps us to be updated with the latest tech and vulnerabilities and CVEs by just communication, and that's the easiest way to get through with all this knowledge out there. And the community is important because it provides numerous opportunities, just like this Diana initiative event, where it's a great platform to share experience and express yourself. It is also great to connect with people who share similar experiences. Now that you have this great community and connections, it is time you made a great CTF team with the people you know here, and start learning. This is not just an opportunity to learn new tech, but also to mentor and share your knowledge and build your team skills.
So let's go back to the topic. Why aren't women in security? Yeah, a lot of factors. But hey, there are a lot of external factors, and we are here to talk about what you can do to decrease the gender gap in the field. So our answer to this question is form a girl gang and increase the number of women who are interested in cybersecurity. So forming a girl gang is great because you see all these amazing women working there, and you get a strong sense of empowerment and you get inspired to work. You also have more opportunities for growth. At least some of you might have faced some kind of discrimination at your workplace because you're a girl. But hey, you don't have that in a girl gang, and you have more people you can relate to, and yeah, there are people to back it up. There are some amazing men out there, and both my mentors were really great, and they were really supportive of me. But there's always this one person. Also, you have more people who can back you up. In short, it's just really fun. So, as mentioned before, we are part of a team called Team Shakti, and it's India's only girls team. It's a student team, and it's comprised all girls. And it was formed to motivate and encourage students to join cybersecurity and to help women explore the various opportunities provided. The team was formed on Jan 2019, and so far we have organized workshops, seminars, a bunch of our women have got scholarships, etc. So this year we'll be organizing a ShaktiCon CTF and a conference, which is organized completely by women, and we hope to see you there. So coming to a conclusion, what finally matters is you have to be passionate about your subject. Whatever you are interested in, you have to know it and you have to want it. And if you really want it, you'll finally get it. So I hope you enjoyed our talk. Any questions?
All right. Well, thank you very much, Meenakshi and Sandhra, for that. That was the pre-recorded portion of the talk, and we're just going to try and get Meenakshi and Sandhra on live with us now so we can take some questions. And so as soon as we can get them on, we will dive into the questions. Meenakshi, hi.
Hi.
Is Sandhra joining as well?
Hello.
Can you hear me? I heard you a moment ago. I just want to make sure you can hear me okay? Okay, awesome. And I think Sandhra was trying to join as well, right? All right, while she's just getting on, if anyone has questions for our presenters, please do go into the stage chat and post your questions there. And I will be posing them to the team here in just a moment. While we're waiting, Meenakshi, why don't you tell us a little bit more about how you got into CTFs and why that was something that got your attention?
So basically, when I got into college, I really had no idea about cybersecurity. But then we had one of these clubs called Team BIOS, which is a CTF team. I think you've heard about it. So I decided to join that, and that's how I got interested in the cybersecurity. Then I met a lot of people doing different kinds of interesting stuff, and I got introduced into CTFs, and it was a great experience.
Awesome. And I think, you know, there's lots of us that have dabbled occasionally in CTFs and far fewer that kind of spend their whole time focused on that. But I know from my point of view, one of the things that I just get stumped by a lot when I look at that stuff is the crypto challenges. And so when you were looking at that, obviously you've both focused to some extent on those. I know they're part of a lot of CTFs, but what attracted you to the crypto side of it, and what do you see as being like the challenges and the ways in which you have been successful and unsuccessful with the crypto side of the challenges?
Well, there's always a point where you'll get stuck with stuff, but then I think it's my teammates that inspired me to kind of not get demotivated when I am stuck with a challenge. Also, when you play CTFs and you solve anything and get the flag, the sheer excitement of it, it's just amazing. And I guess that's the most awesome way that you could get introduced to cybersecurity and stay on it.
Awesome. What you were showing us earlier with the debugger side of things, the tools that you were showing there, I think, are all open source tools. We know a bunch of those, but I am not as close to this as I should be, and I did not come here prepared with a bunch of questions for you. I'm hoping some folks will put questions in the chat for you. But I know as I was looking at it, I can't remember the name of it, but there was a tool, there was a debugger, sort of IDA tool that I remember using a number of years ago that I didn't see in the list. I was surprised not seeing the list. Is Ghidra like the top runner right now? Is that really kind of what everyone's using nowadays?
I think Sandhra will be more.
Okay. Yeah, I know she was trying to join. I was just texting with her, but I don't think she's able to get on right now, unfortunately. And wish she could. But I know she's in the chat for anyone that's trying to chat with her there. And again, if anyone has questions for the team, please do throw them into the chat window in the stage chat. So what else is on your mind, Meenakshi? I mean, you finished up with a few seconds of conversation about diversity and inclusion. We're here at the Banana Initiative. We're very pleased to have you presenting. But was there anything you wanted to get off your chest that you didn't really have a chance to do in the allotted time on the video?
So thanks a lot for the opportunity to present here, and we really had fun preparing the talk and stuff. So what we want to, the reason why we just chose 45 minutes is that we believe that you guys should really try out a challenge rather than us going to the walkthrough.
Of course.
And you guys should really try out the challenge and get the excitement of finally getting the flag to just be excited about it. So that's what we wanted to convey, and we really hope you guys will be more into CTFs after watching this talk.
So I noticed halfway through your video, you had a browser window open that you could see all the tabs on there, and I saw Try Hack Me was one of the ones you had open. What is your commentary for people that are just getting into this around which different sites to go and try and do, whether it's hacking a box, whether it's an explicit CTF, whatever? What are your comments around which ones are good for what?
So for beginners, you guys could just try out some high school CTFs. That would be a very fun way to start. That includes just basic level challenges, and with time you could just increase your level of difficulties and just go on to try out challenges from more difficult CTFs. And for women, we are organizing a CTF called Team Shakti CTF, and that will be around December or January. We'll be announcing it soon. So I think that would be a good opportunity to start.
Excellent. So has Team BIOS competed in anything outside of India yet? How much have you been doing with the global CTF community?
We are currently among the top 25 CTF teams in the world. You could check out
Awesome.
CTF Time, which lists out the.
That's great. How many folks are there in your team?
Around 60.
Oh wow. Okay.
Yeah.
So have you gone into the?
So that's from all.
Have you been doing all the DEF CON
we have
calls?
4 years.
Did you try and get into the team this year? Were you in the team this year? For the team?
Yeah, our seniors were in the team list for the DEF CON finals. 2 of our 4 years finalists were Siddharth Murli and Shasta Vasan. So they both were there for the DEF CON finals.
So what do you think of the Order of the Overflow? What do you think about the Order of the Overflow? Do they do a good job? Think of the guys that run the CTF. The guys that run the CTF. I was asking about the guys that run the DEF CON CTF. You know what your comments were on how they run that.
1 second, I think I'm having.
Oh, no worries, no worries. So I'm guessing everyone needs to go get some more coffee this morning on the chat. We haven't got a lot of questions in the stage chat here, but I want to, certainly again extend our thanks to Meenakshi and Sandhra for their talk, and I think it was a great intro for folks. And if you do have any questions, please do throw them in the stage chat. And we're going to be getting ready in a few minutes for our next speaker, but in the meantime, I think, no, that was not Sandhra trying again. That was, I thought Sandhra might have been trying again for a second there. But yeah, thank you very much. We have a question here. So no, it's I'm going to read it out anyway, because I think you'll appreciate hearing this. So we have one of our audience is saying, I love your level of excitement, and I learned a lot from this talk. I'm going to go work on my first CTF and try to feel the joy that you described. Thank you very, very much for this talk. So I think that captures what a lot of us are thinking.
Thank you so much. Thank you so much. And we feel really awesome.
All right.
And yeah, thank you for watching our talk.
Super. All right.
And thanks for the opportunity.
Well, thank you again. And I hope you get a chance to watch some of the other speakers today. And to experience some of the rest of their initiative. I know if you haven't already played with it, we've got the networking feature as well, where you can get connected and chat to random folks who are also looking to network, and there's all kinds of other bits and pieces on the website. Thank you again. Sorry that Sandhra could not get on with us, but I know she's in the chat, and I'm sure you and Sandhra are both going to hang out there for a little bit. So appreciate it, and have a very good rest of your day. All right, awesome. We're going to get ready for next talk now, and I'll reset the stage. Thanks.